Okay, now we are done with our ATS for three source of power to alternate three source of power. This is a inverter system. This is inverter and solar supply. Okay, now I want you to pay attention, please. Now, I don't want you to design any logic for cool down duration. Okay, don't design any other logic for cool down duration. Take this principle to do your ATS. Okay, now let's take away this and let's do our remote start here, the start signal here. Let's do our start signal here. Let me do that and I will show you. Okay, let me walk you through once again on how to disable the genset to shut down. Three means of shutting the genset down. If I operate emergency push button, just look at the whole of this place will open. Once I operate it like this, look at four of them open. The genset will shut down. Look at it. Now, that is the one means of shutting the genset down. Then, if here also open, that is if mains contactor close and here open, the genset will shut down. Let's try that now. Main is active, is counting. It has entered. Look at it here open. The genset will shut down. That is second means. The third one is by putting this on manual. Putting the genset on manual. You don't want it to start when mains fail. You activate here. Look at it. Here is open. So when you do that, genset cannot start because here is open. Okay. All right. So this is your remote start. Go to genset. I showed you the terminal. Go to genset. Take it from here. Supply here. Supply here. Supply here. Go back again and return it to the second terminal. So this is your remote start. So essentially, this is your ATS for three source of power. Remember that this one is utility. When this one is on, these two cannot come in. Then when this one is not available, okay, now which one of these you want to come in? Which one of these again should come in absence of this? So you have to decide that too. So how do you decide that? The way you disable this is the way you're going to disable here. So when do you want this to come in? So let's do that. Let me show you something. Okay, let me suggest for you. This is our priority power, our prime power. I want you to take inverter as the second prime power so that when utility is not available, inverter should take over. Then when the inverter is low or is not active, that is only where the standby should come up. So I want inverter to be second priority. Remember that we still have switch across all of them to disable them manually. So if you don't want inverter, knock it off. If you don't want gen, knock it off. If you don't want utility, knock it off. But the first priority is utility. In the absence of this, inverter should take over. When the inverter is not active, then standby genset should come up. So in that case, we are going to restrict here not to come up until let's get a contact. Let's get a contact from inverter logic. So this is K3. Once K3 close, here should disable. Okay. Once K3 close, here should disable. The only means here can come in is when this inverter is not active, then here will be closed. But once inverter is working, here is going to open. So let's simulate that now. So let's put on the inverter. Okay, now let's put on inverter now. It's counting. Now inverter has taken over. Look at here is disabled. This is K3. The contactor of K3 from inverter will close. The auxiliary here will open. So genset cannot come in unless the inverter is not active. That is only when genset will come in. And when this inverter is also working, okay, we want here this remove start to also get disabled. Okay, so we are going to open here and insert another auxiliary contact so that once inverter close, the contact here will open here, also open here. So let's fix it here. K3. This is K3. You see that each time I want to design, I will do it with you. I don't want to do it and explain to you. You see the reason why I introduce the fault bit by bit, so that I know the reason why we put each symbol. Before I put one symbol, I will tell you, I'll first of all simulate, I tell you that we need this symbol and this is the function. We now add it. Okay, so let's simulate again. I put inverter on, it's counting. Yeah, inverter has taken over. Now, inverter disable here means not to enter. Also disable the gen not to start. Remember that even means, this means do that too. So supposing the inverter is working now, okay, the mains come active. Let me put on mains. You can see that mains has knocked off both inverter and the mains and the genset. This one has taken over. So this is the prime. Look at it. Look at their contact. You just disable them all until this one go inactive. Now mains has gone out. Utility has gone out. Inverter has taken over. You have seen that this one is now second priority. All right. Okay, so we are done with our three sources of power. Okay, now I want you to pay attention again. The cooldown duration for the genset to cool down before shutting down. Every digital genset comes with that feature. So don't bother putting it again so that I will not complicate or make your logic complex. So take away that shutdown logic. Don't put another timer. The genset will have it. And I don't want you to design analog logic for ATS. Don't do that. Concentrate on your digital because that analog, you need extra relay function. You need to study relay more before you do that analog. So, but I have a good news for you. Analog now, that analog that key will turn, you start and leave key, is facing away for generators. The modern generators now for analog does not use that key. You just turn the key and leave it, it will start. Then when you turn the key